Hello, class. This is the recording for how to conduct repeated measures ANOVA in our homework. And I've just opened up and set up the file for everyone in SPSS. And remember, you will have three variables. So you'll have an ID variable, a positive mood variable, and a neutral mood variable, and a negative mood variable, right? So really what we're comparing is how each participant, that would be each line here, so 1, 2, 3, scores on either the positive mood, the neutral mood, versus the negative mood tests. So when we go through our assumptions for this test, of course we have to do the level of measurement, and that is if it's interval or better, which this data is. Whether the sample is representative, we're going to assume that. And you can look at the scenario for this. Your sample size. Remember, your sample size has to be 30 or above, so you can make the judgment there. And then the normal distribution, and I'll let you run the skewness stats and whether things need to be transformed or not. And then homogeneity of variance. With this, we don't need that because we only have within subjects. So the new ones we're going to test, or new assumptions, are assumption of sphericity, range of scores, and then we're going to assume compound symmetry. So to do that in SPSS, we hit Analyze, General Linear Model, Repeated Measures. We're going to define our factor, that's this right here. So we're going to call that mood. And since we have three measurements mood, our number of levels would be 3. Then we hit add, and then we hit define. And in define, it shows our repeated measures analysis box. And it's pretty simple. All you have to do is take mood, and I click shift, highlight all of them, and then move them right here through this arrow. So that moves all of your variables into your within subjects box. We need to know plots. So we're going to click on plots, and we're going to put mood on our horizontal axis, and we're going to hit add. We can do line charts or bar charts. I like to include error bars and use the confidence interval radio button. You could do bar chart, but the line chart is more appropriate because they're the same people. And so when the line connects negative to positive to neutral, it's actually the same people. And I think it's a better way of doing that. So hit continue right here. Now you're going to hit on options. So we want to know the descriptive statistics. We want to know the effect sizes. We do not need to click on anything else, and we hit continue. The post hocs, it won't allow us to do that in SPSS, so I'll have to show you how to do that afterwards. So if you click on that, see how it doesn't let you do anything. It's kind of frustrating. All right, and then you just hit OK. And it will give you an output file. So this first one just says what the measurements are. So right here we have positive mood, neutral mood, negative mood. Now, here's your means and standard deviations, and you can either report this in a table or report this in text format and sentence format. You always want to report your mean standard deviation and your sample size. So your mean for positive mood was 17.42, your neutral mood was a 10.565, and the negative mood was a 10.92. All right, so that kind of gives us an indication of where we're at with our data. The first thing we want to check is sphericity. And that is tested by Mauchly's W test. And that is this table here. And so our Mauchly's W stat was a 0.622. And you're going to report this in your assumptions paragraphs. Your degrees of freedom is right here. And then your significance right here. So what does that mean? That means that we do not have the assumption, or we did not meet the assumption of sphericity. The simple solution to that, which is great, is that it allows us to read a different line in the test of between subjects effects. This is your ANOVA table. So we can read either the greenhouse gas or the Hundfeld or the lower bound. And in this case, because the lower bound is Excuse me, not, and in this case, we need to choose which one is closest to 1. And if we look up here, 7.25 is the greenhouse gaser, 7.58 is the Hohenfeld, and then the last one is lower bound. So this is the closest to 1, so we're actually going to read the Hohenfeld. So we would read in this line, our degrees of freedom is 1.57, right? And then our error, so our error would be 37.924. Our mean square is 5.03. Our F statistic is 75.763. Our p-value is less than 0.001. Remember, it doesn't equal 0.000. And our partial eta squared is 0.752. So that basically what that means is 75% of the variance is assumed or explained with this model. The one that we haven't talked about is the range of scores in terms of assumption. And the assumption of the range of scores is making sure that when we look at positive mood, neutral mood, and negative mood, we want to make sure that they all have the same range of scores. Not that they're all the same scores, but that they're all on the same distribution of range. And in this case, I believe it is 0 to 20. And so it's making sure that each condition is on the same range of scores, and then you meet that. And so to report it, you're going to report in your assumptions, your Mauchly's test. In your main analysis, you're going to report your ANOVA table or ANOVA statistic, and you're going to use the Hohenfeld. You didn't do a test of between subjects effects, but you also want to include a figure. And the figure demonstrates or illustrates your effect. This one's a little deceptive because of the scale of the y-axis. So if you double click on that, you can always change it. You double click on that and you click scale right here, and you want to go minimum is going to be 0. If you did auto, excuse me, don't click auto, hit 0, and it's 0 to 20, and then hit apply and hit close. All right, so that gives us kind of basically what the scale is supposed to look like. And hit that. And so we don't know this yet because we have not run post hoc analyses. But this right here is, I want to make sure, yeah, positive mood, negative, and neutral. I believe that's how that goes. No, excuse me. Positive mood, neutral mood, negative mood. Positive, neutral, negative, right? So we don't know where the differences lie. We only know that there's a difference among these three. So we need to run post hoc analyses. To do that, we go analyze, compare means, paired samples. Remember, this is a within subjects test. So we click on paired samples, and we need to do the number of pairs that we have. So our first pair is going to be, I'm going to hit shift, click on one variable, click on another, and move it into my pairs. Now I'm going to go positive mood to, and I'm going to move that in there. And the second one's going to be negative mood. And then the last thing I'm going to compare is neutral to negative. So that completes all combination of pairwise comparisons. Click on options just as a good way. Yep, exclude, we're good. And hit continue. All right, so now this tells us, this is our post hoc analysis. This tells us where the differences lie. So if we look at it, here's our means and standard deviations, and you're gonna want to, you've already reported those, right? Don't look at the correlations, but we do want to look here. So when we compare positive mood to neutral mood, right here tells us there's a significant difference. And then this is the t-value, right? And we know that positive is significantly higher than neutral. When we compare positive mood to negative scores, neutral scores, it is significant. And we know that positive is significantly higher. This is the t statistic for it. Then when we compare neutral to negative, there is no difference. This is above 0.05. So that's what you're going to report in your post hoc analyses. And you can see that right here in terms of significant difference to here, significant difference from here to here, but no difference between this point and this point. If you have any questions, please let me know. Email me as always, and we will have a discussion and write it up in the APA format and submit via Blackboard. Thank you.